try some partial fraction decomposition examples where we have quadratics in our denominator. Specifically quadratics we can't factor or we know don't have real solutions. So for instance, here in this example, we know that if we put in any real number for x and square it, we'll get a positive number or 0. And then when we add 3, it'll definitely be bigger than 0. So we know that there's no roots or no solutions to this quadratic. So we know that we can't factor that. We have a quadratic factor. So in order to propose a composition for this particular example, we treat the linear factor just like we did before. But then remember that we have to treat the quadratic factor a little bit differently. Instead of just having b over this, we need bx plus c. Then we can proceed as we were before. So we can actually multiply each piece times this denominator so that we get our polynomial. So here the x minus 1's will cancel. We're left with the quadratic piece. Here the quadratic piece will cancel. So we're left with the x minus 1 and we're multiplying that by the whole term bx plus c. So there is our polynomial. So we need to think about values of x that will be particularly helpful to us. The only one I see is 1, because that will make this term 0. So let's start with x equals 1. So I get 1 squared plus 3 times 1 plus 4. That's equal to a times 1 squared plus 3. And this whole term has disappeared because this is 0. This should be a plus 3. Let's step ahead here. So this should be 8. And this will be 4. So I get 8 equals 4 times a. When I divide by 4, I'll find that a is equal to 2. So there's my first of my unknowns. Now, I don't know any x's because there aren't any. That will make this 0. That's the whole reason that we couldn't break it down further. So, let's think of another x value that will be particularly helpful. In general, we use x equals 0. It's probably a good bet. It's easy to work with. It'll also make our b term disappear, so hopefully we can find c. So I have 0 squared plus 3 times 0 plus 4 is equal to a times 0 plus 3 plus b times 0, so just plus c times 0 minus 1. But I know a. I just found a, so let's use that information. A is 2. So what I get is that 4 is equal to 6 plus negative c or minus c. Now I can either move the c to the other side and the 4 to the other side, or I can move the 6 to the other side and multiply by negative 1. Either of those will work. We'll end up with c is equal to 2. So again, either I can move my c over here, my 4 over here, or I can move my 6 to the other side and then I need to multiply by negative 1. So there we have a and c. Now we just need to find b. So let's just pick another relatively easy value of x to work with. So let's say negative 1, since we've already used positive 1. So I get negative 1 squared plus 3 times negative 1 plus 4 equals a times negative 1 squared plus 3 plus b times negative 1 plus c times negative 1 minus 1. So 1 minus 3 plus 4 will give me 2. And then I have 4 times a, but I know that a is 2, so I'm going to go ahead and put that in. Then I have plus minus b plus c, but I know what c is, 2. And then I have negative 1, minus 1, so minus 2. This minus 2 needs to be distributed. So I have plus 2b once those are multiplied, and then a minus 4 for my second term. So when I move the 4 over to the other side, I get that negative 2 is equal to 2b. So when I divide by 2, I'll get negative 1. So let's go ahead and put those in. So c we said was 2. B we said was negative 1. And then A was also 2. And there we have it. There's our partial fraction decomposition. Let's look at this second example now. This one is very similar. We know that this quadratic is never going to have a 0 or a solution because this will be positive 0 or bigger. This will add 1, so it's always going to be bigger than 0. So I need to set this up the same way. I can take a over x plus 3, but then I need my bx plus c over my x squared plus 1. So now let's actually go through and multiply by the denominator so that we get our polynomial. So this denominator, if I multiply it here, will cancel. So I get x minus 2. Then I have a, and my x plus 3's will cancel, so I have just the quadratic term, or the quadratic factor. Then this piece, I'm left with bx plus c, that whole thing times the linear factor. And then we have our polynomial. So now we need to start thinking about values of x. So I'm looking at my linear term. Negative 3 will make that 0. So that's probably the first value of x I want to use. Hopefully that'll then get me my a. So I'll have negative 3 minus 2 is equal to a times negative 3 squared plus 1. And then this whole term is going to be 0 because this piece is 0. So negative 3 minus 2 is negative 5 is equal to 10 times a. So when I divide, I get a is equal to negative 5 over 10, or negative 1/2 when you simplify it. So there's our first unknown. So because we can't make this 0 to make the a term disappear, we can use x equals 0 to make the b term disappear. That's the next best thing. So 0 minus 2 is negative 2. Then I get a times 0 plus 1 plus b times 0, which then just becomes 0. So plus c times 0 plus 3. But I know a. Again, I just found a. We need to use that information here. So I have negative 1/2 times 1. That'll give me negative 1/2 plus 3c. So I'm going to rewrite my negative 2 as negative 4 over 2. So I have a common denominator. So I just multiplied by 2 over 2. So now when I add this to both sides, I'll end up with negative 3/2 equals 3c. Now I need to divide by 3, but that's the same thing as multiplying by 1/3. So these 3's cancel, and c is also going to be negative 1/2. So now we need a way to find b. So we haven't used x equals 1 yet, so let's do that. That's probably going to give us the easiest arithmetic. So I have 1 minus 2 is equal to a times 1 squared plus 1 plus bx, or b times 1, plus c times 1 plus 3. Well, this will be negative 1, and I have 2 times a, but a is negative 1/2, so I'm going to plug that in. Then I have plus b plus c, so I have minus 1/2 times 4. So now I need to distribute this 4. So 2 times negative 1/2 will be negative 1. Then I have plus 4b. Then minus 1/2 times 4 will be minus 2. So the 3 I can add to both sides. I'll get positive 2 is equal to 4b, which means when I divide by 4, b will be equal to 1/2. So we have all our unknowns. So let's plug them in. So a was negative 1/2, b was positive 1/2, and c was also negative 1/2. So there is our partial fraction decomposition. Okay. Let's try another example. It'll look a little bit different. This time our quadratic is going to be x squared plus x plus 3. So because this x here could be positive or it could be negative when we're talking about a real number, it's harder for us to tell whether this is ever going to be 0. So what we can use is actually the discriminant, which is part of the quadratic equation. It's the part under the square root, so it's b squared minus 4ac. If that's positive or 0, we know that that quadratic does have real roots. If it's negative, then we know that it does not have any real roots, which is what we're talking about here when we have quadratic factors. So here, b is 1, so 1 squared minus 4 times 1 times 3. So that's going to be 1 minus 12, definitely negative. So this quadratic indeed does not have any real solutions. So we need to treat it just like we have been in these quadratics here. So I'll take ax plus b over the quadratic, and then just c over the linear factor. And notice that I switched around the order that I'm treating them in. Before I was doing the linear factor and then the quadratic. It doesn't matter since it's addition, it'll all come out the same. So let's now go through and create our polynomial. So I'm going to multiply by this times each fraction. So here it'll cancel, I'll end up with 1 plus 2x squared. Here, my quadratics will cancel, so I'll end up with ax plus b all times x plus 1. And then here, I'll be left with c times my quadratic. So now we're just left to find good values of x. Well, I notice that negative 1 is going to make this term 0. So that's probably a good place to start. So I get 1 plus 2 times negative 1 squared. This term is all going to be 0 because this is 0. So I have c times negative 1 squared plus negative 1 plus 3. So I get 3 equals 3c. Well, that means that c is going to be 1. Okay, let's try another value of x. Again, so that I can get rid of this a term, I want x equals 0. So I have 1 plus 2 times 0 squared equals a times 0, which is 0, so b times 0 plus 1, plus c times 0 squared plus 0 plus 3. But I just determined what c was. It's 1. So let's actually just put that right in. So what I get is 1 is equal to b plus 3, I can move the 3 to the other side. So b is going to be -2. So let's choose as our last value of x in order to find a. Let's choose x equals 1. Again, just for the ease of the arithmetic that goes on. So I have 1 plus 2 times 1 squared equals a times 1 plus b times 1 plus 1 plus c times 1 squared plus 1 plus 3. But we know c, rather, that's 1, and we know b, that's -2. So now we should be able to find a. So 1 plus 2 times 1 is 3. Then we have a times 2 when I distribute, so 2a, and then a -4, plus this term, so plus 5. So I get 3 is equal to 2a plus 1. Move this to the other side, I get 2 is equal to 2a, which means that a is equal to 1. So when I go back up here, I get x minus 2 and then 1. So there is our partial fraction decomposition. Let's look at one more example. So let's take 3 over x squared minus 3x plus 2 times x plus 2. So notice we have a quadratic factor and we have a linear factor. But we should double check to make sure that this quadratic can't be factored or doesn't have real solutions first. So if I take the discriminant, I get -3 squared minus 4 times a times c. Well, that gives me 9 minus 8, which is +1. So that means that this quadratic does have real solutions. And in fact, I can actually even factor it, because I need two numbers that multiply to be 2, and then I can add to get -3. So that should be x minus 2 times x minus 1. So now I have 3 distinct linear terms. So we're back to that very first type of partial fraction decomposition. So I can write this as a over the first factor plus b over the second factor plus c over the third factor. So there's nothing tricky here. I don't have any repeated factors. I don't have a quadratic that I can't find real solutions for. So we're back to this type. So let's find our polynomial. So I need to multiply by each of these 3 factors. So this term, I'll just get the 3 since the denominator will cancel. Here, I'll just get a times x minus 1 times x plus 2. Here, I'll get b times x minus 2 times x plus 2. Here, I'll get c times x minus 2 times x minus 1. So there's our polynomial. Now, we're back to the situation where we have 3 specific x's that will be helpful to us, that are all going to make terms go away. So this term will be 0 when x is equal to +1. So I get 3, this term will be 0, this term will also be 0, so what I'm left with is b times 1 minus 2 times 1 plus 2. So this is -1, this is 3, so I get -3 times b, which means that b is going to be -1 when I divide by -3. So there's our first unknown. If I let x equal -2, this term is going to be 0. So I get 3, this term will be 0, this term again will be 0. So then I have c times -2 minus 2 times negative 2 minus 1. So this term will be negative 4 times negative 3. So that'll be positive 12 times c. When I divide by 12, c is actually going to be 1/4. And last but not least, this term is going to be 0 when x is positive 2. So we get 3 equals a times 2 minus 1 times 2 plus 2. This term will be 0, this term will be 0. So we get a times 1 times 4, so 4a. So a will be 3/4. So we have 3/4 minus 1 and 1/4. So be careful, if you see a quadratic as a factor in the denominator, we need to double check whether it can be factored or has real solutions before we start doing it this way. Because if it does, we need to treat it differently.